Okay, today we're going to be showing how to calibrate the TCM U3, our top-of-the-line color display, graphing display, ultrasonic hardness tester. The probe is identical to the probe that we use on the TCM U2, the baby brother of the device, and on the end of the probe we have what we call the puck. This covers the probe itself, the tester, which is the diamond tip. So if I screw this off, we can see on the end of the probe, hidden here by the shroud, is the diamond tip. And the reason I'm showing you this is there's actually two parts to doing a test. It's all one fluid motion. The first one is the resistance, that is the spring in the puck to press down. And then the second resistance is actually when the diamond tip contacts the part, and it's the second motion, very short, to actually bottom out on the face of the probe itself. So when this is screwed on, and you can leave it off for a more experienced user, you can use it without this puck and just use the device like this for doing testing. But for a new user, it's much easier to use it with the puck attached. So the motion for testing is press down initially to take the resistance of the spring, contact is made with the diamond tip, and the second motion is to bottom the puck out on the face of the shroud, and the test is done. So what I'm going to do here is to do a test on 3 different test blocks. These are all HRC test blocks. They are made in the US, they are NIST traceable, and these are an option that goes with the device. The reason we sell them as an option is because many customers already have a bench tester with similar calibration blocks, so there's no point buying a secondary group. So on the side of the test block is the hardness of the block, and here it's saying it's 23.17, and for your convenience I've written here in pen what the hardness is, and it's telling us that the tolerance of this block in terms of hardness is 1 HRC. Second block is a little harder, and this is 47.3, and the third one is a 64.31 test block. The device has gone into its timeout mode, so it's a little duller and it's showing a clock. I hit any key and I can then activate the display. Here we have the measuring, calibration, archive to look at the prior tests, settings to change the brightness of the display and so on, memory card to save the settings from the test probe back to the device because the probe has its own memory, then information which is about our company, number of tests done and so on. So I'm going to hit the middle mouse button to go into calibration, because you can see here if I move around it changes the size of the icon larger. So here we are in calibration, and right now it's showing that we have one calibration. It is for HRC. Next to it would be HB Brunel, and then Vickers. HRB only used when we've got attached is the D-type test probe. And then down here are different material types. Then we have alloy steel, stainless steel, cast iron, aluminum, and so on. The non-ferrous ones are ready for the D-type probe, which is different than the ultrasonic because this model can have that attached to it optionally. So we're going to calibrate for steel because these blocks are steel blocks, and I need to use the return key to go into there. If I use the middle key here, it goes into what we call user calibration, and this is what is defined here on the bottom of the display. We want to do the master calibration, so it's this key. What is displayed is 3 hardness values. It's showing right now there is 200, 500, and 700. These are the defaults, and we're going to change the display to be the value of these test blocks. To do that, we use the return key. And you can see here that the number 2 has a little blue box behind it, and this little blue box means that that number 2 is currently activated. So if I use the cursor control keys here, you can see I can scroll up and down to go to different values. So I want to make this 0 because this is a 23.17 test block. I then use the right cursor key and it moves the little blue box to the next value, and I use the cursor control key to change this to 2. Again, this is 23.17, this is going to be 3, and because we're working with 1 decimal place, we don't put in 17, we're going to round this up to 2, so it's going to be 0.2. I use the return key, and this now allows me to move the cursor and drop down from its yellow current display here to the next one, and this is yellow. I hit the return key to turn the numeral 5 with its background blue, so I can now scroll it to 0. This is a 47.3 block, so just quickly moving along here, change this to 47.3. That's the 3, hit the return key, I go down to the next one, and this is a 64.31. So at the return key, the numeral 7 has the little blue background behind it, so I can now use the cursor control key just to change its value. So there is 0. We'll make this 6, 4, and then the last one is 3. That's it. So now I'm going to use the cursor control keys. I could start with the hardest block here, but I'm just going to go backwards up to show you that if I move this up and down, I change the selected line, it turns into yellow. So here, this is the 23.2. What I need to do is to use a heavier part. I can't just go onto my plastic table here or a wooden table. I need to ring it to something heavier to get the most accurate result, and what I have here is actually a lead calibration block. I flipped upside down so I can ring the part to this, so now when I'm doing a test I'm getting the most accurate result rather than the vibration passing through the test block and potentially giving us an inaccurate result. So putting the puck over the test block, both fingers around the outside, fluid motion down, contact, and we hear a beep. Now we're watching for the number here on the right hand side. It says 1646 right now, and we don't want this to deviate much. So this is base 1000, so if it jumped by 10, it's less than 0.1%. So we're just watching to see if this changes by very much at all. So I'm just going to move around a little bit. So that's 5.8, tiny little change. 6.9, a little bigger. And if I don't like that one, I can just hit the backspace key here, and I'm just going to do another test. 6.4. Okay, so I'm happy with that as my first calibration. This is a code. It really means nothing to the user, but it's a code stored on the device. The higher number means it's a softer material. So I'm just going to go down to the next one. And so now I've highlighted the second line in yellow, and I'm going to put on my 47.3 calibration block. I ring it to the part, so now it's almost stuck to it, and it's thinking that the part is heavier and denser, but we're actually just testing the material on the top, not all the way through. Again, doing a very fluid motion, press down, 122.3, 1236, moving a little bit more, move around. A minimum of 3 is required to make sure that there's no user error. And you'll notice that when I'm doing the test, I have everything aligned always the same to minimize any sort of error. So I've got the cable pointing away, and each test that I do is always with it aligned roughly in the same place, because then I know that I'm removing any potential chance for errors or things that might creep in to give me some erroneous tests. All right, so now I'm just going to go to the third block, which is a 64.31, ring it to the part. I move my cursor down so that now this is yellow and on 64.3, and I'm going to do 3 tests or more here. So here it says 946, 949, 952, 953. So I've now done the calibration. To store this in the device, in the memory of the probe itself, I hit the backspace button, and it comes up and says, well, you've done these calibrations, do you want to save it? No would be hit the back button here, or as the icon shows, yes is to save it. So now it's display scrolls. I've now calibrated this test probe for that material steel for those 3 test blocks. So let's just go back out of here. I'm going to go to measuring and just show you now some tests. I'm just going to show you initially that this is a little icon that shows that the diamond tip has made contact with the part. But if you press down and you just make that contact without that second motion, you will get very, very wildly varying results, because what's happened is when the diamond tip contacts the part, it then sets the little coil inside to start the vibration of the rod to do the test. But because I haven't followed through with that second motion to press down to actually have the test done correctly with the correct load, in this case 12.5 pounds, I'm not getting an accurate result. So I'm just going to backspace here over and start again to do the test correctly. So I have a 64.31 test block. There it is, 64.1. 64.3, obviously very, very accurate. Let's go to a 47.3. I'm just going to hit the backspace key here to get rid of those, so I've got a good start point. So there's 47.8, off by 0.5 HRC. 46.3, off by 1. 47.1, and you can see here on the display is the little movement of each of the tests showing in graph form. So considering the block is a 47.3, you can see it's extremely accurate. Let's look at the last one. This is the 23.17. Again, I'm not just plonking this on top, I'm ringing it to it, so I want to try and get the most accurate result that I can. I'm going to hit the back space button here to take me right back, so there's no tests have been applied. And 23.1, and there is the block 23.17 or 23.2. So there we go. This is a brief overview of how to do calibration. Very, very simple. If you wanted to do calibration for additional materials, you would then go back into the calibration mode, move your cursor around, for example stainless steel, SST. You would hit the return key and go through the same steps that I did. You probably wouldn't have calibration blocks, but you'd have your own materials in stainless steel of 3 different hardnesses, known hardnesses. They don't have to be polished like this. They've got to be a good surface finish, of course. But then you can calibrate the unit for your own materials, titanium, very exotic stainless steels, very exotic sorts of materials that are difficult to test otherwise, are great for an ultrasonic tester. Thank you.